Scott?
Okay, well, thank you very much, Michaela. I'm very excited today to talk about the line extension for both the ePIV and energy valve, which is the ANSI 250 rated assemblies that help us to go after some new target markets and expand our market share within this market segment. As we talked about earlier, or as Michaela talked about earlier, it is titled an advanced performance solution for higher pressure applications. So I'll cover a little bit about the agenda of what we're going to cover today. First, we're going to talk a little about valve evolution to understand how we arrived at where we are with this solution today. Going to cover some of the basic components so you have an understanding of how they're comprised and what they're made of and how they interact with each other. I'm going to talk about some basic specifications, and so you understand from a pressure and temperature standpoint of where these can be applicated within an HVAC system, describe some features and benefits, and then conclude it out with some marketing materials. So let's talk a little bit about valve evolution. So in 1999, Belimo entered the control valve market with the characterized control valve. Now, primarily before that, Belimo was known as an air actuation company, but through a lot of the advances that made a technology with air actuators, they saw a very good relationship to where they could apply as to control valves. Since 1999, we have sold more than 5 million characterized control valves with a very, very low return rate for quality. So it's something we've had very good success with, and it's a very stable product line for us. Around 2003, we introduced the PICCV, which is a pressure-independent solution, which is a mechanical pressure-independent solution. And we followed up another introduction to that mechanical pressure-independent solution last year with the PIQCV. But what we're talking about here today is electronic pressure independence. So achieving pressure independence not by a mechanical pressure regulating system, but by using a flow sensor and control algorithm based within the actuator. So what we'll talk about here today is both the ePIV and energy valve, so you see a little bit of the legacy of how these were derived. So if you look in the center of your screen here, you see the ePIV. On the bottom portion of the screen, you see the ANSI 125 version, which we currently have in the marketplace, and our newly launched ANSI 250 version of the ePIV. To the right of that, we have the energy valve, and on the bottom, once again, we have the ANSI 125 version, and up on top, we have the ANSI 250 version. So with a pressure-dependent valve, typically the DDC signal responds to a specific valve position. Then when you start moving towards pressure-independent valves, that control signal now directly correlates to a specific GPM. So we've taken that even one step further with the energy valve, where now we have some further advances with a control technology. And one of the things that we have is what's called power control. So not only does it respond to pressure independence by maintaining pressure independence flows of either increase or decrease within a system, flow across the ball is going to remain constant at its set GPM. But with power control, we have the ability to correlate that DDC signal directly to a BTU output. Now, for some specific applications, if they want to control to a specific BTU, they can set their DDC signal and it will correlate directly to that BTU output and modulate to maintain that BTU. It also has what's called Delta T Manager, which provides a delta T limiting function, and we're going to talk a little bit more about that later, but basically what that does is what's known very well in the industry as low delta T syndrome. What it helps to do is maintain the coil design at a specific delta T set point, for example, of 10 degrees. So if the coil is set for 10 degrees, the energy valve would modulate flow through that valve to maintain that design 10-degree coil delta T. And as I said, we're going to talk a little bit more about that in the subsequent slides. We also have separate webinars available for power control and for delta T management. So if you'd like an even a finer in-depth detail understanding of those, we recommend you check those out as well. So let's talk about the components of the ePIV. At the core of any assembly is a control valve. And this assembly right here uses a globe valve. combined with a linear actuator. And what this really shows too is the ability for Belimo and innovative design to utilize different control strategies and different technologies across different platforms. So we not only have this technology, ePIV technology integrated across ball valves, but also have it integrated across glow valves as well, showing once again the ability to really adapt their technology to different products. A real credit to our engineering team, and it's been very well received within the marketplace so far. We have the flow meter and the flow housing. The flow meter itself is an electromagnetic flow sensor, a very high quality flow sensor that we've been using in these assemblies since 2009 when we essentially initially launched the ANSI 125 versions, and is coupled together with the flow housing, and those there together require a 5 times the DN size inlet run to remove turbulence, which is very typical with flow meter installations to create kind of a laminar flow so we have stable flow measurement across the assembly. So that covers the components of the ePIV. Now let's talk about the energy valve components. Once again, they're very similar. We have a control valve, once again at the heart of the assembly. Now we also have an actuator, but this actuator here has additional technology built into it. The energy valve is clearly the technological leader in the valve portfolio for Belimo, and in my opinion, leading the marketplace as well from a technology perspective. This actuator itself has a lot built into it. It has, first of all, it has an integrated web server. That integrated web server allows you to connect to a valve over TCP/IP connection for remote setup and remote monitoring. There are valves located in our Hinwil, Switzerland home office that I can connect to from my office here in Danbury. So it allows me to look and see what's going on with the valve real time, and look at flow. I can look at delta T and many other parameters, again, real time. The actuator itself also has what's called BACnet interoperability. So it has BACnet MSTP and BACnet IP integrated right into the actuator. Now, one of the other things that's integrated in this actuator, which makes it very powerful, is a data logger. This data logger has the capability of storing 13 months worth of data for trending and analysis. Many of the data points that I just talked about, of flow, delta T, valve position, heating energy, cooling energy, all of those are stored within the actuator for 13 months and can be exported through some tools that I'm going to talk about in a little bit later slides. So a very powerful actuator, not what we call as a shared logic, or a very smart actuator that we have integrated into this assembly. The flow meter is now a BTU meter because we add 2 temperature sensors on this assembly. And that's how we understand the delta T and how we conduct our delta T management. By having these 2 temperature sensors, and one temperature sensor typically goes on the supply side of the coil, and this valve is typically installed on the return side of the coil. By having the difference between the supply and the return water temperature across the coil, we can understand the delta T. And now that we have flow, we have delta T. By using the formula flow times 500 times delta T, we can extrapolate to BTU. So now we not only have a flow meter, but we have a BTU meter as well. So that provides us a very, very robust solution, and a very and all assembled in a compact or somewhat compact package compared to if all these components were being installed separately, independently on their own. Let's talk a little bit about the product offering. The product offering itself, I'm going to start up top with the ePIV. And ePIV is available in sizes from 2.5 inch through 6 inch, from flow rates from 38 GPM all the way to 713 GPM. So 2.5 inch would be the 38 to 127, and then a 6 inch, of course, would be 214 GPM all the way to 713 GPM. And the way these valves are configured is they are shipped from our factory, configured at what's called VNOM, so the highest capacity flow rate of the valve. And then the valve can be set all the way down to 30% of VNOM, or the highest capacity flow rate of the valve. So in the case of the 2.5 inch, it can be set all the way down to 38 GPM. Now what we provide with each unit that ships is what's called a ZTHUS, which is a handheld field programmable device. And what that allows you to do is to set the flow in the field for each unit. So it provides a very flexible way. It simply connects to the top of the actuator with a connector, a simple quarter turn click, and you can set not only the flow, but there's some other parameters like the control signal, just to name a few. It allows for the customer to set the flow to whatever flow setting they want in the field. It's available in both non-spring and electronic fail-safe actuation. So that would cover the ePIV offering. The energy valve down below is very similar. So it's 38 to 127 for the 2.5 inch, and then 214 to 713 for the 6 inch. And you can see the corresponding flows there. All of these flows are available in our product flyer and, of course, our PGPL. Again, once available in non-spring return and electronic fail-safe. But with the energy valve, we have a little bit of increased flexibility for setting the flow due to the high technological ability of this actuator. Once again, what we can do is we can preset the flow at the factory for the energy valve. So in the case for the 2.5 inch, if they wanted it set all the way down to 38 GPM for some specific reason, that can be done here at the factory. So when it leaves the factory, it's already set when it arrives on the job site. So it just shows a little bit, once again, the flexibility and the technological advantage of the product lines. So that would cover both the ePIV and the energy valve and ANSI 250 version product offerings. I'd like to cover some of the specifications with you now. I'm contrasting these with the ANSI 125 because some of you may be familiar already with our ANSI 125 version ePIV and energy valve, so I'd like to make that correlation to make the transition a little easier for you. As far as the body pressure rating, it is fully compliant with ANSI 250 specifications as opposed to the 125 version of the ANSI 125 versions. The media temperature, they are both identical for 125 and 250. That would be from 14 degrees Fahrenheit to 250 degrees Fahrenheit, or minus 10 degrees C to plus 120 degrees C. Service, they're both capable of water and up to 60% glycol, pretty constant within our valve range. The differential pressure range, there's a little bit of variation there. Requires a little bit higher differential pressure with the ANSI 250. So it's 7.5 to 50 psi differential as opposed to 5 to 50 psi differential with the ANSI 125 versions. They can also operate at a lower differential pressure. Some of the things that makes a pressure-independent, electronic pressure-independent solution unique in the marketplace by giving that flexibility to operate at lower differential pressures. The valve technology itself, as we talked about before, through innovation, we've been able to provide this technology in different valve platforms. This one, ANSI 250, now uses a G6CS-50 250 globe valve, so as opposed to the ball valve style, the LGCCV and the ANSI 125 version. The body materials for the 125 is a GG25 as opposed to the cast iron ASTM A126 Class B of the ANSI 250. Close-off pressures on the ANSI 250 vary by size and actuator configuration, anywhere from 135 to 310, and close-off are 100 on the ANSI 125 versions. The warranty is standard across the line for both of these assemblies. And our Belimo 5-year warranty is once again a true testament to the reliability of our products, being able to offer such a robust warranty for an application or for products that are going to be in very demanding applications. Talk to you a little bit now about some of the features and benefits. And these features and benefits here carry across to both the ePIV and the energy valve. So these here, what we're talking about here is the flow sensor. And one of the most attractive features of and actually benefits of the flow sensor is that it has no moving parts, similar to a pad or impeller type or wheel type flow sensor. Those impellers could be clogged with debris within the system and produce inaccurate flows or even to the worst degree stop operating. These here have no moving parts, so are much less sensitive to debris within the system. These sensors themselves are completely maintenance-free. They are calibrated before they leave the factory and do not require recalibration in the field. They also have a very strong accuracy rate of plus or minus 2% of the flow and repeatability of plus or minus 0.05%. So it's a very robust sensor. It is an electromagnetic sensor that I talked about before. So this here is going to be very well adapted for these particular applications. I'd like to talk a little bit now about some of the benefits across the entire energy valve line. And I say the benefits across the entire line because the energy valve, much like the ePIV, go all the way down to the half-inch sizes. So this once again shows the diversity and the technological capability of our engineering team to expand our products across different platforms and different valve styles. So the first thing we talk about here is measures energy. As we talked about before, we have temperature sensors on both the supply and the return of a coil. So now we have the ability to measure BTUs. Flow times 500 times delta T gets us to BTU measurement. So that BTU measurement can be used for various applications. It could be used for monitoring to understand how much consumption a particular air handler is using. Another thing that can be used as well is for diagnostics. Let's say a coil was cleaned and they want to ensure that they get an improvement in performance. They can run the energy valve prior to cleaning the coil or repairs made on the coil and run it after to see if the improvements and BTU increase and delta T increase that they were looking for are actually achieved. I'm going to talk a little bit more about in the next slide about how we can look at some of that data after it's been stored. Also has the ability to control power. As we talked about before, with that DDC signal correlating directly to a BTU output, now it gives us another way to control the space or the temperature in the space directly to a BTU. So for some critical application environments where the BTU output is absolutely critical to the space, there's now a way to directly correlate that within the space, something that no other product in the marketplace can currently do. Another thing as well that we talked about earlier was Delta T Manager. What the Delta T Manager does is it looks at the difference between the supply and return water temperatures and compares that to the delta T set point, which is typically the design delta T. So an example we used prior was a 10-degree delta T. So what it would do, it was look and understand to where that delta T set point is in relation to where it wants to be controlled. And if that delta T set point drops below the desired delta T, the delta T manager would engage within the valve and it would modulate flow through the valve to achieve the appropriate delta T. Now flow and delta T are inversely proportional, so as flow goes down, delta T goes up. So in the case of delta T dropping, it would modulate flow through the valve down until the desired delta T is achieved, and then the delta T manager will be disengaged. So as I said before, there are separate webinars for both power control and delta T manager, and if you'd like to know more about those, I recommend signing up for one of those subsequent webinars or looking at one of the recorded versions that we have online. One of the other things as well, as I talked about, is this integrated web server. Now this is a very powerful feature. Can be connected to the valve over TCP/IP connection and look at what's going on real time within the valve. This is the image you see on the upper left portion of the screen. We can look at flow, so you can see the actual flow going through the valve at any specific time. The flow changes, decreases, or increases. We can look at what their supply and return water temperatures is, power, what the delta T manager activation is, or if it's not activated. We'll look at heating and cooling energy, just to name a few. So this gives a very powerful way to log into the valve and see real time and make changes real time of what's going on within the system. Now, as we talked about earlier, the energy valve actuator has a data logger built into it, and it stores up to 13 months of data points that I just talked about: a flow, power, valve position, supply and return water temperature, heating and cooling energy, just to name a few. And what we provide free of charge is a data analysis tool. So you could take that, export that data out of the actuator, which comes out in a comma-separated value file, import that into the data analysis tool. And the data analysis tool is simply just a macro to pull that, to align all the column headings and bring it right into the data analysis tool, So you can look at it all in a graphical representation. So you can see graphically what's going on within your system. So give you a little bit different look and a little bit different understanding of what we're talking about. Some of the things that we talked about earlier with maintaining a system. This is the perfect tool for that. That way you can actually see a coil trend based on before and after to see if the desired increase in BTUs was achieved. Another powerful thing that's integrated into the data analysis tool is it will help calculate a delta T set point suggestion. Now when a new coil is installed that has a design delta T, but 20, 30 years later or after a period of time that coil becomes, the heat transfer degrades for various reasons. Dirty coils, damaged coils, various reasons. And that design delta T can no longer be achieved. So there's really no way of understanding what that new design delta T could be. That's where the energy valve comes in so handy. You can put the energy valve in a system, run it for a while, get a load profile on that coil, extract the data set, and run it through the data analysis tool. And the data analysis tool will actually calculate a delta T set point suggestion for you to run your system at. So a very powerful tool, and all of these, including an integrated web server, are provided free of charge. There's no additional software to download for this web server. It's all integrated right into the actuator. As we talked about earlier, it's also completely integrated with BACnet MSTP, and BACnet IP. So a very powerful actuator. Let's talk a little about some of the target markets that we could achieve here. These are very similar to existing chiller and coil applications, so basically large air handling units. District and heating and cooling applications are an ideal target for these. Cities with high rises over 5 stories where larger pressures are being required. Some of those systems are split, but some of the lower floors or even higher floors do require higher pressures and require the ANSI 250 pressures to meet those specifications. And of course, large universities and campuses with district heating or cooling would be an ideal target for those as well. So some of the similar markets for those of you that are familiar with where the current ANSI 125 versions are, but these here are just allowing to expand the applications for the higher pressure applications. Talk about some of the marketing support that's available for both the ePIV and the energy valve. Of course, we have the submittals that are all online on our Belimo website. These can be found for both the ANSI 125 and ANSI 250 ePIV and both energy valve. Those are available via download currently today as we speak. The technical documentation for the ePIV has been fully updated as well, and it's included the ANSI 250 specification in there as well. So now it covers the entire line, all the way from 1/2 inch to 6 inch, covering both ANSI 125 and ANSI 250. So if you're looking for one comprehensive documentation of all the technical documentation based on the product line, this would be it as well. The 2016 PGPL has been updated with the ANSI 250 versions. If you are currently a Belimo customer, your PGPL should be arriving at your doorstep very shortly if it hasn't arrived already, and it's also available on our website as well if you want to look at it today. EnergyValve.com, there's a site that is dedicated directly to the energy valve. All the information related to energy valve that I was talking about before is also available on the site, along with other presentations and some of the other webinars that I was talking about earlier as well. As well as the ePIV technical documentation, there's also a energy valve technical documentation, which again is one single document that houses all of the technically related documents to the energy valve itself. So kind of a one-stop shop where all the information is. And as well, there is a ePIV flyer and energy valve flyers as well. So both of those are attached to the presentation as well and available for your download. As I said, all this information is available on your website. And if you're looking for additional information, I would suggest that you contact your local Belimo sales representative or send us an email here at Belimo at marketing.support. And we could get you in contact with a specific DSM or regional sales manager in your area to give you more information.
All right. Thank you so much, Scott. For any of you who are interested in downloading those product flyers, there is a section in your on your GoToWebinar screen that says handouts, and you will find the ePIV and energy valve brochures there where you can download. Without in just a couple of moments, we're going to have our question and answer session. While you are typing those questions, just want to give you a friendly reminder that this webinar was recorded, so that if you should join us, maybe you joined us halfway through or you had to step away or take a call, it is being recorded and will be emailed out to you within the next day or so, so that you can review the presentation in its entirety. All right, so a couple of questions. And if you do have questions, you can use the question box, send the question through, and then I will read the question aloud, and Scott will answer it as best as possible. So Scott, are you ready?
Oh, I am ready, Michaela.
Awesome. So your first question is, can you change the BTU calculation to adjust for changes in specific heat and gravity when brines are used?
The units can be changed for BTU, so it can be changed to tons or kilowatt hours and so forth. But the energy valve itself is probably not the best application for brine. So what I would suggest there is contact either DSM or contact me directly, and we can kind of work through that application to get you the best information and the best result of what you're looking to do within your application.
Okay, next question. Are there requirements for straight run beyond the dimensions of the valve?
The only requirement is 5 times the DN size on the inlet to the flow meter. That's the only requirement. There's no outlet. There's no requirement on the outlet of the valve, just only on the inlet side for the flow meter, and that's to reduce turbulence through the system.
Okay. Next question. Did you say that the ZTH is supplied with the ANSI 250 energy valve?
I'm sorry, could you repeat that question? You broke up there.
Sure, no problem. Did you say that the ZTH is supplied with the ANSI 250 energy valve?
No, that is only supplied with the ePIV. It is not needed with the energy valve because the flow can be pre-configured at the right from the factory for the energy valve. One nice note too about being supplied with ePIV is that gives you the capability to connect right to the actuator, and there's a magnetic back on the ZTH, so you can actually connect that right to the actuator, stick it to either the valve or piping within the system, and now you have a scale or a digital readout of what the actual flow meter is, what actual flow reading is. So not only do you have a way to set the flow, you have a digital readout of what the actual GPM is going through the valve. You can also do that as well with the energy valve, but we do not supply the ZTH with the energy valve.
Okay. Couple more questions. What mediums will this be best for? Thinking of a food processing application.
Again, process applications get to be a little tricky. Probably not something that we could comprehensively answer on this webinar. So once again, I would recommend contacting me or your local DSM directly for the best answer on that one.
All right. What is the easiest way to remotely monitor the valve?
It really depends on your system. I mean, if you have BACnet, that's probably the easiest way to do it. If you don't, you can run it through TCP/IP and run a standard Ethernet cable to it, and you'll be able to connect to it that way.
Okay. And one final question, are all the sizes available for purchase now?
Yes, all sizes are available. We've been shipping for a while now, and initial orders have been very positive, very pleased with the initial response we've seen from the marketplace so far. But yes, all are completely in stock and available to ship today.
All right, last question, excuse me. Have these valves been used as a chilled water bridge valve?
Not that I'm aware of. I'm not aware of them being used in that application, but that probably, once again, would be a good place to follow up with us directly.
All right, well, Scott, thank you so much for your excellent presentation, and thank you, audience, for taking the time to join in on our webinar series. I do want to advise you that we have an upcoming webinar on Wednesday, March 2nd at 1 p.m. Eastern Standard Time, and that's going to be on basic actuator troubleshooting tips and tricks. And if you should come up with any last-minute questions or ideas, please feel free to email us at marketing@us.belimo.com. Thank you so much, everyone, and have a great day.